If you were standing on top of a house in the Bay of Fundy in Canada and the tide was coming in, do you think you'd be safe? Well, it depends a little bit on the house, but the tide rises and falls by 13 metres in that bay, so unless you want to get your feet wet, you might want to get to shore. Tidal power, where turbines are built into seawalls, is currently the only mature technology available for generating electricity from the ocean. While there are examples that have been operating since 1966, there is still very little electricity generation from tidal movement, and it does not feature in the International Energy Agency's future scenarios. Tidal energy is interesting to us though because it's potentially a very large resource, and although the amount of electricity produced varies over the course of the day, it's highly predictable in both the long and short term, and predictable generation is easy to integrate into an electricity grid. Energy from tide movement can be harnessed using the height differential created by tidal water movement, which is called tidal range, or just by using the movement of water that the tides create. To get energy from tidal range, you need to build a structure of some sort to capture the height difference caused by the tide. This often takes the form of a seawall called a barrage, but it can also be engineered pools cut into the coastline or further out to sea. Turbines are then used to capture the energy as water rushes to equalize the pressure differential created by the difference in height. Harnessing energy from tidal flow is a bit like underwater wind power. A turbine is installed where the water flow is just right. Often these are areas of good flow where there is a narrow opening for the sea to flow, like in between islands or at the mouth of an inlet or bay. These tidal barrages and turbines can rotate on horizontal or vertical axes, depending on the water depth. And they can be conventional, where they only work when the tide is flowing in one direction, or they can work when the tide is flowing in both directions. Turbines that work in both directions are not as efficient as conventional ones, but they do work for twice the amount of time. Where you put your tidal device is reasonably well understood as well. To have sufficient pressure difference to drive the turbine, you just need somewhere where either the tide movement is 5 metres or greater, or where the water flows faster than about 1.5 metres per second. However, building tidal pools or barrages can cause other environmental issues. Barrages change the natural flow of water in the marine system, and so they can damage the delicate coastal ecosystem by stopping pollutants from dispersing, causing a reduction in water salinity, and increasing silt buildup. Barrages with their high-speed turbines can also damage and stop the movement of marine life. Tidal energy is costly. Barrages are expensive because they take time and are complex to build. Costs are expected to come down as other tidal technologies mature and ways to build reliable, durable equipment in the marine environment are discovered. But as with wave power, the lack of good data makes it difficult to predict when this will occur. On the positive side, the capacity factor for tidal systems is between about 22 and 40%, which is comparable or better than other variable renewables. Tidal systems with fast-flowing water generally have a higher capacity factor than those that have a bigger range between the high and low tides. Tidal power is potentially a large and predictable energy source, but it comes with high costs and, depending on the type, some large negative environmental impacts. There are some long-term projects out there, such as the River Rance in France, which has been operating since 1966. But the fact that you're in the ocean with its salt and sea life means that the hurdles are large and they may take some technology leaps to overcome.